test for slope of regression lines. We can also test the hypothesis about the value of the slope, beta. The most common hypothesis is that the slope is 0. In other words, that there is no linear relationship between x and y. That means that y does not change at all when x changes. When testing on whether or not a linear relationship exists, the null and alternate hypotheses are h0, that the slope is 0, and ha, that the slope is not 0. If we wish to know if there's a positive linear relationship, we'll use a greater than with the alternate, and a negative linear relationship, we'll use a less than 0 for the alternate hypothesis. The test statistic is our slope that we found from our data divided by the standard error of that slope. So in the confidence interval section, we had this example. We wanted to know if round 1 of a golf game affected round 2 scores. We found in this that the regression equation was 26.332 plus 0.6877x. We also found that the standard error of the slope was approximately 0.23. Our test statistic will be our slope divided by the standard error. So 0.6877 divided by 0.23 is 0.299. Now for this one, we want to see if there is a relationship at all. So our h0 is that the slope is 0, no relationship, and our ha is that the slope is not 0, that there is a relationship. This is a two-tailed test. So with a two-tailed test, remember our p-value is actually twice the probability that t is either less than or greater than the test statistic. With a positive test statistic, we use a greater than. If it were a negative test statistic, we'll do less than. So we're going to do TCDF on this, or PT in RStudio, and we're going to make sure to multiply it by 2. And remember, our degrees of freedom is n minus 2 on these instead of n minus 1, which is 10. This gives me a probability of 0.0136. This is less than, we weren't given an alpha, so remember when we don't have alpha, we'll assume that alpha is 0.05, so that we have good evidence here. This is less than our alpha, so we will reject our null hypothesis, which says that there's no relationship, in favor of saying that there is a relationship between round 1 and round 2 scores. Here's another example. This one gives us the partial computer output from data relating the number of pages contained in a magazine to the number of full-page ads in a 2-year period. N is 24. This makes my degrees of freedom equal to 24 minus 2, which is 22. Determine if there's strong evidence to conclude that a large number of pages in the 2 magazines will also have a large number of ads. So large number making large number means that we have a positive slope. Our null hypothesis again is that there is no relationship, a slope of 0, and the alternate will be that we have a positive relationship. Our test statistic will be our slope divided by our standard error of the slope. Our slope is the coefficient of our x value, pages, so it's 0.25986. The standard error of the slope is the standard deviation in that same row. And this gives me a test statistic of 3.01637. So for my p-value, we're going to do the probability that t is greater than, matching my alternate, 3.01637 with 22 degrees of freedom. This gives me 0.00317, which is less than 5%. So we have strong evidence to reject our null hypothesis, which says there's no linear relationship, in favor of saying that we have a positive linear relationship between our two variables.